So does anyone have anything over the homework that you want me to discuss? Number 21. Okay. So we're talking from, what page is that on? Page 7, is that the one you're referring to? How many 3/4 cup servings are in 2/3 cup of yogurt? Okay. All right, so how many 3/4? So remember what I said about changing things to try and make them make more sense to you? So how about this? How many 3-cup servings are in, I can't write today, are in 9 cups of yogurt? That help? Okay, so you look at, you've got the yogurt here, right? We'll just say this is a vat of yogurt. There's 9 cups in there. How many 3-cup servings go in there? 3. So how are you doing that? I mean, you know it's 3 because 3 goes into 9 3 times. So what you're really doing here is taking 9 and dividing it by 3, right? That's what you're doing. So now just go back to the problem and replace 9 with what? 2/3, and replace the 3 with 1/4 or 3/4. So for your problem, you're doing 2/3 divided by 3/4, and that's division of 2 fractions. When we do division of 2 fractions, we convert first to multiplication. So 2/3 times 4/3, right? We flip the second fraction over. And then you can multiply straight across if there's no canceling that takes place. So what happens here? 8/3? What? 8/9, sorry. Hold on, I'm trying to confuse you. What's that? Yes, 8/9, but what is it? 8/9 what? Servings. Because it says how many 3/4 cup servings are in here? I don't know after my experience from last class with you whether or not to trust these answers, but I'll tell you what the key says. Yes. Do you have one specifically, or? What I wouldn't mind doing is like just somehow sharing the key with you. I can't distribute it electronically, but I could, after class or before class, let you come take a look at it. Does that work? That way you have some idea? Okay. Any others you want to discuss? How many of these cupcakes would that one? Okay. Okay. So how many cupcakes would the mix make? It should have been 6 cupcakes. Did you get 6? And then you should have 1/6 ounces left over. Shall we discuss it? Okay. Sheila was making cookies for the school parent-student dinner. In the blender, Sheila knew that she had to put in 13 2/3 ounces of ingredients she had to mix together. After she was finished, she poured the mix into 2 1/4 ounce cupcake tins. How many of these cupcakes would one batch of this mix make? How much mix would be left over? So she has how much mix does she have total? 13 2/3 ounces of mix. She poured 2 1/4 ounces for each cupcake, right? So she pours in those little containers, whatever. And so when she does that, the question is how many times does the 2 1/4 go into the 13 2/3? So we're going to be dividing 13 2/3, dividing it by the 2 1/4. So we first convert these mixed numbers into improper fractions. So 39 41/3 divided by 9/4. Ooh, should I cancel the 9 and 3 here? No, right? Got to flip first, right? Flip first. So convert this division to multiplication, flipping over. And now the canceling went away. I don't have it anymore. So I have no choice but to, I can look diagonally, but nothing happens. Straight down, nothing happens. So straight across we multiply. What's that? 164 over 27. Is that good? Now that's the answer as an improper fraction, but it's difficult from that to tell how many actual cupcakes she made. So now it would be worthwhile to go back into the mixed number. So, so how many times does 27 go into 164? So you might get your calculator out. You multiply it times, like 2, 3, 4. You get to 6. What's 27 times 6? 27 times 6? Okay, 162. And look, we have 164 here. So 27 goes into here, what, 6 times? So we have 6 cupcakes. I should have done it like this. Make it a little easier. Do the 164 divided by 27 like this. It goes in there 6 times. That's 162. We're left with 2, right? So our remainder is 2 27ths. So you have 6 cupcakes and 2 27ths of a cupcake left, right? 2 27ths. What does it say? Yeah. So this is a little more complicated. Yeah, it's a little more complicated. Well, let's think about this. First, let's interpret what this answer is saying. I'm going to try and do it visually. You can make 1 cupcake, 2 cupcakes. Did I already tell you about my drawings? Did I talk to you all about that last time? I've been doing this for a long time. So if you are, if you can't make cupcakes that look that good, don't get discouraged, okay? Look, 6 cupcakes, right? That's what I can make. But I have how much left over? 2 27ths of a cupcake. That's right. So hold on. All right. So look, I've got a cupcake. I had a cupcake bin here that I could have filled up, right? All these got filled. Each one took how much in it? How many ounces went into each one? 2 1/4 ounces. What I know is that I have left in this last cupcake here on the bottom, right? I wasn't quite able to fill that up. I had 2 27ths of a cupcake, right? That's how much I would have had left over. Yes? So what you're trying to figure out now is how much did it take to make a whole cupcake? 2 1/4. You're only able to, 2 1/4 ounces. You're only able to produce 2 27ths of that 2 1/4. So you have to take this and multiply it times this. It's confusing, I understand. See, the 2/27 is how much cupcake you have left. It wants to know how many ounces you have left. What if you had one cupcake left? I know that doesn't make sense, but what if you had one cupcake left? How many ounces would you have? 2 1/4. What if you had half a cupcake left? What would you have? 1 1/8, right? But you don't have a full cupcake left or half a cupcake left. You have 2/27 of a cupcake. So you're going to multiply. I can do it right here. You're going to take the 2 1/4 and you're going to multiply it times the 2/27. Now I need to convert that mixed number. We already did that. 9/4 times 2/27. And we get good canceling here, don't we? Because multiplication straight across, we don't have to flip. 9 goes into 9 once. 9 goes into 27 how many times? 3. 2 goes into 2 once. 2 goes into 4 twice. And you multiply straight across and get what? 1/6 ounces. Tricky problem. The first part of it, is that okay? This part? Okay. Anything else? You're requesting I put this on the test? Oh, I misunderstood you. All right. Well, let's get going with today. We're supposed to do a quiz. Now, my normal procedure will be you walk into class, we do a quiz right over the homework, right? I mean, that's what I want you to be ready for. This is the first week I'm gonna spare you that walking into a quiz, but I want you to be expecting it next week. What I'm gonna do is like we did last class, somewhere either in the middle or towards the end, we'll do a quiz. All right, and we'll just kind of see how you do with today's material, and it might be a group quiz. We'll see. I'm gonna take it easy on you this week. All right, we left off last time right here. Remember this? We were on page, what was it, 11? And we had worked through the first 4 problems. We were doing operations with polynomials. And now it's time to continue. And we were trying to do the operations correctly on this expression. So remember the, please excuse me, oh, did we say PEMDAS? We never said, please excuse my dear Aunt Sally. That's the way I remember, or I learned it. Anyone learn a different way? You learn that way also? Please excuse my dear Aunt Sally, whatever. You need to just have a way of remembering it. I'm going to start with parentheses. So anything in here, can I combine any of these together? 3x minus y minus z minus 5. Nope, no like terms. Okay, next thing I do is look at exponents. Do I have any exponents? Yes, 7 squared. I can figure out what that is. That's 49. So I'm going to go ahead and put an equal sign. Y minus 3 times 3x minus y minus z minus 5. And then after everything, minus 49. And now I move to the next operation, which would be multiplication or division, whichever occurs first from left to right. Let's see what I have. Y minus, that's subtraction, so I don't do that. 3, what? 3 what? That is times, right? That is multiplication. So I need to do that multiplication, and that's it. So that means I need to distribute this. I need to multiply the negative 3 through to every single term in the parentheses. Whoa. So y, I'll have negative 9x plus 3y plus 3z plus 15. And I do not need the parentheses anymore, right? That's the whole reason the distribution occurs, because it removes the parentheses. But I still have the minus 49 out here. And now I try and collect like terms together. And I'm just going to go through and highlight the things that are like. So I have a y here, got a 3y here. I only have one term with x's in it. I only have one term with z's in it. But I have 2 terms that are numbers. So I can put those together. So let's just start with the. Yeah, we agreed the ones that didn't have any friends would come down first. Right? So we'll just bring those down. Now let's do the y's. How many y's will I have? 4. Y plus 3y, 4y. And then 15 take away 49, negative 32. And we are done. Is it 34? I'm just listening. I'm not really paying attention. Where's the key? My brain doesn't like to do math like that. My brain is, for some reason, it's not wired that way. What's that? You know what? It was warm in the other room the other day, right? Yeah, let's see what this, you know what, to answer your question, no, I can't control it, but let me see what this says. 73.5. I don't think so. Whoa. Shit. I heard it turn off there. It's back on. You know, maybe the door being open. I don't like the door being open, but see if it's. We'll leave it open and see if that helps. All right. Next problem. Perform the indicated operations for the following polynomial expressions. So I have a big set of parentheses around 3 separate terms. I've got another set of parentheses here. In between the two, I have the operation of subtraction. So what we want to do is we want to kind of visualize that out in front of this first parentheses as like a 1. See it? And then this minus right here really represents a negative 1, right? And to get rid of parentheses, you must distribute the whatever's out in front of it through. Now, when I distribute a 1 through this parentheses, it doesn't change anything, right? 1 times anything is itself. So essentially, the first set of parentheses just goes away. We're lucky. Now, on the second set of parentheses, we must distribute a negative 1 through. Anytime we distribute a negative 1 through parentheses, it just changes the signs of everything that was there. So if it was positive, it becomes negative. If it was negative, it becomes positive. So I'm going to have a negative a minus 2a squared, and a plus 3a cubed. And then it's like term time. So let me look for a's first. Got a 3a here, minus a there. My a squareds, I've got a 2a squared. I have a minus 2a squared. Oh, that's nice. And then I have a 3a cubed, and then I'm going to add to it another 3a cubed. So in the case that there's nothing that stays, we just pick which one we want to work with first. So any preference here? You can go 3a. Let's do the a's. 3a minus a. 2 a's. How about the a squareds? They cancel each other out. And then we have 3a squared plus 3a squared is 6a cubed. Stays the same. Because you're adding, the only time you can add things together is if it's the same variable to the same power, which we have a cubed. And in the case that you add the numbers in front only. Now, if you were to multiply them, that's when it would become a to the 6th, but it would have been also 9a to the 6th instead. But that's multiplication. So this is correct, and so is this. They're both 100% full credit on a test, all right? But the one on the right is called descending order, meaning that, notice the power on the a is cubed. That's higher than just a, right? So descending order means the powers come down as you move from left to right. And a lot of times later on, we want descending order, but it's not less right. You can turn the table if you want, like rotate it. You're okay? And same with this. If y'all want to move this at all around or something, feel free. Okay, next one. Oh, yes, fractions. Okay, do we have to worry about the parentheses on both of them? No worries, right? There's a 1 out in front here, and then in front of the, or after the plus is a 1 also. So the parentheses there are just to make sure you know when you can and can't drop them. So I'm just going to rewrite everything, no parentheses anywhere. Please keep in mind that everything we've been doing in here last class and today is still considered review, right? All right, let me look for like terms. I've got a 3a. Let me search for any other a's. 6a plus 6a. Search for my a squareds. I've got 2a squareds. I've got minus 2/5 a squared. And then a cubes, I've got these. Now, I know you don't have highlighters like I do. Well, some of you do. But one thing that I've done in the past when I'm writing with pencil or something is like I'll circle the a's. I'll put boxes around the a squareds. And then I'll put like cheesy triangle or something around, just so I can tell the differences. And then as I go through, I just kind of cancel out what I've done. Okay, let's get our a's. How many a's? 9. A squareds? Uh-oh. So for the a squared, what we have to do is look at the coefficient of this one. Coefficient meaning the number in front is 2, positive 2. The coefficient on the other one is negative 2/5. So that really means I'm going to subtract 2/5 from this. So I need to figure out what that is, 2 minus 2/5. And then whatever that answer is, I'll tack an a squared onto the back of it. So common denominator, right? Because these are two fractions. 2 over 1 minus 2 over 5, which is 10 over 5 minus 2 over 5, which is 8/5. So how did I get the 10 over 5 here? You could use 10, but the least common one would be 5. So I multiply the top and bottom by 5 here to get 10/5 there, and then right there I do 10 take away 2, that's 8, and then the 5 stays because it's subtraction. So I'm going to put here a plus because it was positive 8/5, and then a what? Squared.
So you don't want it to be 1 3/5?
I prefer 8/5 actually. The mixed numbers, you know, like with the cupcake problem, it made more sense to convert it to a mixed number because it was like 6 cupcakes. But for something like this, the improper fraction is preferred. Okay. We've got to do the last one. For the last one, what's the number in front of the a cubed? Positive 3/5. And we need to subtract from that, what, 3? Which I'm going to write as 3 over 1. So I'm doing that right there. 3/5 take away 3, which is 3/5 take away 3 over 1. Common denominator again. I'll multiply the second fraction top and bottom by 5. And then do the subtraction. 3 take away 15 is negative 12 over 5. So negative 12/5. So that means when I put it in here, I put minus, right? I need the minus in there. Minus 12/5 a cubed. All right. That's it. Oh, no, it's not. One more addition problem, and then we get into some multiplication. Man, this one does not look fun. Because there's so many fractions, right? 2/7 a. I'm dropping parentheses. I can do this only because there's ones in front and it's a plus in the middle. So I sure wish this one right here was a squared, but it's not. There we go. I'm going to do this one a little faster, okay? I'm not going to show the fraction stuff on the side. I'm just going to assume that you could do that if need be. All right, so I'm going to take 2/7 a, and I'm going to add to it a, which is really a 1a. So I need to take 1 and add 2/7. 1 and 2/7 would be the improper fraction, or sorry, the mixed number. It'd be 9/7. So 2/7 plus 1 is 9/7.
So if we put 1 and 2/7 and 1, it would be 9.
I've never seen polynomial arithmetic, which is what we're done with mixed numbers. I've never seen it in any book or usually once you start having variables within your expressions, you completely dump the mixed number notation. So that is the preferred way. Now I would have a hard time taking off because it's not incorrect, but you need to be able to add fractions together. 1 plus 2/7, you should be able to come up with 9/7. All right, what about the next one? 2 take away 2/7. 12/7 plus, right? And then 3/5 take away 3. Negative 12/5 a cubed. Okay, now again, I didn't show the work on the fractions, but does everyone understand what they would have to do? Okay. Okay, up to this point, everything we've done between these polynomial expressions has been addition or subtraction. Now we're going to do polynomial multiplication. So when you see this 5 minus x in parentheses squared, squared means multiply something times itself, doesn't it? 5x minus 2 times itself, 5x minus 2. So we want to write this 5x minus 2 times 5x minus 2, like that. And then to multiply these together, how do we do it? FOIL. Oh, everyone's going to say FOIL. All right. FOIL is that little cute word we use to help us remember how to do this. It means what? It stands for what? First, outside, inside, last. That means multiply the first terms together. These are the first ones. We're going to multiply those together first. Then, after we do that, we do the outer ones. The outer ones are this one and this one. And then after that, we do the inner ones, which is this one and this one. And then at the very end, we do the last ones, which is this and this. Do you get what I'm doing there? I can draw it with little arcs, which I'll do in a second. And I think FOIL is fine. But FOIL only works when you have 2 and 2, right? What if you have 3 and 3? It's not like foiling, or, you don't change the word, right? You just don't have it anymore. So what I prefer, you do your FOIL, okay? I'm not here to undo FOIL in your head. But I would like for you to understand it perhaps in a different way. If you understand a different way, then it won't make this one seem so bad. All right. So here's the approach. I want you to start with this guy right here, the first guy in the first parentheses, okay? Take that guy in the first parentheses and hit everything in the other parentheses with it. Hit meaning multiply it. So I'm going to go here to here, then here to here, right? After I've exhausted the first guy and passed him through the second parentheses, you move to the second one. The second one is what? -2. And then you pass -2 through the parentheses. Once you've exhausted that one, you're done. Now, the beauty of that is that it works for this too. See, to do this, what we would do is what? Start with the first guy in the first parentheses, then multiply that through to all three. Then you go to the next guy, and you do the same thing. If you understand that concept, the FOIL restricts you to 2, 2. But this way opens you up to being able to do anything. 4 and 4, you can do 10 and 12, it doesn't matter. Oh, and notice one more thing. If I do this, like I said, I do that first and that first. Isn't that FOIL? Isn't that F? And then isn't this O? And then I was supposed to go to the second one and go here, and isn't that I? And then isn't this L? So it actually is FOIL. Yes. Uh-huh. Yes. Yes. Yeah, we'll do that one. And by the way, when you multiply two polynomials together, a lot of people say like this is called foiling it. The technical term is expanding the polynomials. You're expanding them out into a bunch of terms. So let's do the multiplication. What's 5x times 5x? So this is now we are actually multiplying, right? So you do 5 times 5, x times x. So 25, x squared. And then the next one, 5x times -2. So minus 10x, it becomes negative because a positive and negative multiply to be negative. The inside one here, negative 10x again. And then -2 times -2 is positive 4. So that's the expansion. And now you just make sure you don't have any like terms, which we do. The middle ones, right? Now we have subtraction, right? We have negative 10x. We're taking away 10x more, negative 20x's. And at that point, we'll be done. Any questions? I'm going to pass around the sign-in sheet. Make sure you initial next to your name. Make sure you pass it to the table after you're finished with it. All right. Okay, how about this next one? X minus 3 quantity, that means in the parentheses, times the quantity x squared plus 3x plus 9. -3, that's, yep, just like that. So I'll start with the first guy, which is x. I'll pass him through. So I'll have equals x times x squared is x cubed. What are you doing to get x cubed, just to make sure we're all on the same page? X times x squared. What are you actually doing? It's x to the first power, and so you're adding the exponents. 1 plus 2 is 3. Okay, just want to make sure you're okay with that. And then the next one, x times 3x. The 3 is going to stay there, but now x squared, because 1 and 1 add up to be 2. And then the last one, positive 9x. Nothing you can do with that. So there's your first multiplication through. You have exhausted the first guy. You move to the second. So this one will go here, then here, then here. So minus 3x squared. Then -9, because -3 times 3 is 9, and then you have the x. And then last, -3 times positive 9 is -27. Collect like terms if possible, and I actually do have X squared, ooh. And these. Those cancel, and so since this and this go away and this go away, all you are left with is x cubed minus 27. Questions? No? Yes. When you multiply polynomials together, you get a new polynomial. When you are given a polynomial like this, you can be asked to take it back to a multiplied version, and that's called factoring, going the backwards operation of this. And x cubed minus 27 is what turns out to be a very special type of factoring. We would have to recognize this as being what we call a difference of cubes. And for the difference of cubes, right, x cubed is something cubed, and 27 is 3 times 3 times 3. It's a special cube. And so we'd have to recognize that when we see it, and then we would go to a formula called the difference of cubes formula. So yes, you are correct. We're just not there yet. We're making sure you can go this way before we try and go back. All right, next one. So this one, the intent here is to make sure you know what you're supposed to multiply, that you don't just go crazy and start multiplying everything together. Understanding what the symbols mean, where things stop and start. The first two, the r minus 6 and the r minus 3, those two are multiplied together because there's no sign between them. So those have to be expanded, or in this case we could say FOIL because it's 2 and 2. This one, since this is a minus sign, the only thing I'm going to do here is distribute a negative through. That's it. So let's do this first. Let's do this multiplication. R times r squared. R times negative 3, negative 3r. Negative 6 times r, negative 6r. And the last one? Positive 18. Yep. Negative times negative would give us the positive. Then we're going to need to address that negative right there. So it's got to go through before I can drop the parentheses. So minus minus goes through. So negative 3r, then minus 2r squared, and then plus, careful, that 3 is not there. It's all right. Plus 7. Good. Now collect like terms again. I'm just going to start with the r squareds because it's right there. My r's here, 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 and then my numbers here and here. We've got a pretty good mess here. How many r squareds do I have? 2? 3? I have 1 r squared here, right? That's a 1 in front. And I'm taking away 2. So negative r squared. So you have to remember now we're doing subtraction. So you're looking at the numbers in front. It's not multiplication. So just a negative r squared. How many r's? So negative 3. Take away 6 more is what? Negative 9. Take away 3 more. Negative 12 r's. And finally, 18 plus 7. Plus 25. There we go. All right. So we haven't had this discussion in here. And I actually haven't had it in a long time with the class because, like I told you, I spend most of my time in the calculus classes, so I'm very hard on them because they all want to build airplanes that we're going to fly in later. So why do you have to take this class? Like we all know that, you know, at some point in our lives we're going to be expanding polynomials, right? I mean, it's a good question because I know you probably sit there and, you know, I know I sit here and I think to myself, they're never going to use this. They're never going to use this. So why are you here? I mean, like, why does the state require you to take this course? To weed people out? Well, I want you to ponder it yourself. Okay, think about it yourself. But I'm going to try and give you an answer to kind of encourage you to somewhat stay motivated. All right? Yeah, but see, they split it into two maths, right? There's one for people who need more math, and there's one for people who don't. So why even have a math? Like, if you don't need any more math, then why teach you all this? I mean, this is the math we're doing here is the equivalent of me bringing a hammer and a nail in here and showing you how to use a hammer, but never actually building anything with it. You, so why not this? Why do you have to take any class in college? Like, why do I have to take biology if I'm a math major? Why do I have to take Texas history? Why do I have to take art history? Why do I, like, what's the point? Let's get the hell out of here. Let's go. Why are we, I mean, seriously, we're here for a reason, right? I mean, you have to be. It's general knowledge, right? It's general knowledge. I mean, a degree means something. It means if I'm an employer and I'm trying to hire someone with or without a college degree, the college degree does not mean that this applicant is better than someone without. Okay, it doesn't mean that. All a college degree tells someone is that you're capable of learning. You're teachable, not only with things that you enjoy, but things that you may not enjoy. And that way, does that make sense? Like, if I have to teach an employee how to use a computer program that is a real pain in the ass and they don't have a degree, I don't know, they haven't demonstrated that they can learn, where the degree actually does demonstrate something like that. That's, to me, the reason, the reason for general broad education. Now, you're focusing in other fields, like someone who wants to share their major. Anyone want to share what your major is? Nursing? Okay, so there will be some math in here, especially when we get to like proportions, drugs, and you don't want to, oops, thought that said liters, not milliliters. So there are some applicable things, but there are a lot of other courses that are going to be more important for you. So anyway, okay. Let's take a look at this geometric figure and find its perimeter. Because we all know that's going to happen. What is a perimeter? It's the distance around it. Like if you were going to walk around this thing, it's how far you walked. So you would start at one corner, you'd walk, let's say, to here, then across here, then across here, then across here. And that would give you the total distance around. So I know each of the sides are given to me with these expressions, 2x plus 1, 3x plus 4, 2x plus 1, 3x plus 4. I don't know what they are, but I know that the total distance around is all of those combined through addition, right, not multiplication. So I just need to add all these up. So I need to take 2x plus 1. I need to add to it 3x plus 4. I do not need the parentheses here, do I? No, because I'm not subtracting anything. But I'm putting them there just to stress that it's side plus side plus side plus side, and then you move on, you do the rest. The answer should come out to be 10x plus 10 if we trust the key. All right. We could probably do this just visually. 2x plus 3x is 5x plus 2 is 7x plus 3 is 10x. And then 1 plus 4 plus 1 plus 4 is going to be 10. So it is. That's it. See, you can't tell me the perimeter if you're never given an exact length. All the lengths are in terms of x, so your answer's got to be in terms of x also. Floor space. Find a polynomial that represents the total number of square feet of the floor plan shown below. So this is supposed to be the floor plan of, I guess, a house or an apartment or something. All right? And we want to know the total area. The key here is, where is it? Where did it say area? Square feet. Square feet means area. Anytime your unit is squared, you're talking about area. So you want to know everything in here. And to do that, we recognize it's a rectangle, right? A rectangle. If you know what the length is and you know what the width is, the area is the length times the width. You need to know that. Okay, that needs to be something that's hardwired. So let's talk about the area in terms of what we've got. What is the length of this thing? What is the length? Negative x plus 6. I'm going to write that down. Negative x plus 6. Is it not? Oh, no, it's not. Okay. You could. What if x was 1? This would be negative 1 plus 6, which would still be 5 feet, wouldn't it? But it would make, I mean, it would make sense. 12, negative 1. I understand what you're saying. No, I meant to erase it. Sorry. I agree. I don't think it's a negative sign. No, it's the line right here continued. That's what it is. It's supposed to continue. That's what that length is. Okay, so let's say x plus 6 here, and then how much more? Plus 24. That's just the length, isn't it? We're going to take that and multiply it times the width, which is going to be from here all the way up here, x plus 12. So x plus 30, we do everything in the parentheses first, order of operations. And then we expand or FOIL. If you prefer to say FOILed, that's fine. You're not going to upset me. X squared, then 12x, then what? 30x, and finally 360 times 12. 360. And we do want to put those middle terms together, right? 12x and 30x, which is 42x plus 360. Square feet. That's square feet. I put it at the end to let everyone know that that represents the area. I should have probably put that up here on the previous problem. Didn't it want to know the length around? It didn't say feet anywhere, did it? No, it did not, so I would not put the unit. But here, because it's saying square feet and the units are given in feet, my answer should be in square feet. Yep, cupcakes, ounces, depending on what it is they want. Okay, find the volume of this rectangular prism. It's a box, okay? Use the formula. The volume is length times width, but now you have the additional height unit. So if you know 3 sides of a rectangular shoebox, the 3 lengths, you multiply all 3 together and it gives you what we call the volume. The volume represents, if you were to pour liquid into it to try and fill it up, how much you would pour. So our volume here would be, we just pick which of these we want to call length, width, and height. It does not matter. I'll call this length, I'll call this width, I'll call this height. LWH. So what is my length? X plus 1, I put in parentheses, times the width, which is x, times 4x. Now I didn't put the x or the 4x in parentheses because there's only one term, so I don't need it in parentheses. You have to put the x plus 1 in parentheses. So what should I do here first? It's in parentheses. Can't do anything. So multiply. You want to put these two together first? We can do that and then distribute through. That's okay. It'll be, I'm going to leave the x plus 1 alone. That's 4x squared right here, isn't it? X times 4x is 4x squared. Then, is it okay to distribute backwards like this? Sure. Because it doesn't matter. That 4x squared could be in front of the parentheses. It's the same thing. Multiplication is what we call commutative. It flips over. You can do 2 times 3 is 3 times 2. So that expression doesn't matter. 4x cubed is our first term. And what's our second term? Plus, now we do the middle one, just 4x squared. We were not given any units here, right? No feet or anything. Let's say it was given in feet. What do you think our answer would be? Feet squared, feet cubed, cubic feet. I distributed the 4x squared first to the x, which made it a 4x cubed, but then 4x squared times 1, and then a plus between them. So anything times 1 is itself. If you put them in parentheses, you should still get the same thing. It should still.
So what I did, I guess, was distributed the x to each of those.
To here, here, and here, here. Okay, so let me explain why you can't do that. No, it doesn't change it. It's multiplying incorrectly. Let me show you an example next to this. What if I said what's 2 times 3 times 4? Okay? When you do this, do you do 3 times 2 then 3 times 4? No, you just go 2 times 3 first. That's 6, then times 4, right? If I put these in parentheses, it's the same thing. You see? 2 terms. I had 2 terms. The 2 terms have to be put in parentheses. Because if you don't, it'll look like this. That's what it would have looked like out of parentheses. And then this x would never get hit by anything over here because there's no distribution necessary. There's no parentheses that I have to drop. So all you would do is first put these two together, which would just be x. Then you would do these two, which would be 4x squared. So you would think that the answer is x plus 4x squared. Does that make any sense? Ish. These have to be in parentheses because there's 2 terms. 2 terms.
So let's say you did put everything in parentheses. You did FOIL. You started with the x, and you distributed it out, and you did the positive 1.
See, no, because when you multiply the x, and I said make that x go hit everything over here, the everything I was referring to earlier, they were separated by addition and subtraction, weren't they?
Yes.
These are not. So you would not be able to do that. What you could do is you could put these together first, then hit the x here, then hit the 1 here, and that would have given you the same thing. See, these are the things in algebra that are little tiny little questions, and until you get them really rock solid, you know, it's hard to be really good at algebra until all this is just nailed down. Yeah, and these are great questions. Okay, what the heck is this? I don't see a picture. Is there a picture? A countertop is pictured. Is it on the next page? How are we supposed to do it? Okay, we'll picture it in our minds. A countertop is pictured that will have a hole drilled in it to hold a utensil holder. The area of the entire countertop is given by this, 3x squared plus 12x plus 4. The area of the hole is given by x squared plus 2x plus 1. Write an expression for the area of the countertop that is left after the hole is drilled. All right, that's not so bad. So you have a countertop. No one said it had to be rectangular or anything like that. And what I know is that the area of this whole thing is what? Plus 12x plus 4. Then we're going to come in here and we're going to drill a hole. Going to assume a circle, right? Out of this thing. And the area of that is x squared plus 2x plus 1. So the question is, what is the area of everything remaining after the hole has been drilled out? Subtract, right? You take this area, which is this polynomial, you subtract from it this polynomial. So how about we try that out? I like to add some letters in here. You may not want to. Over here where I have the area, I'm going to put area with a C subscript, and over here I'm going to put H subscript. What do you think I mean by that? Area of the countertop, area of the hole, right? So the area that I'm looking for is the area of the countertop minus the area of the hole, which is 3x squared plus 12x plus 4 minus x squared plus 2x plus 1. Is that correct? That's the area of the countertop. That's the area of the hole. What the heck? Do I need parentheses around this? Why? You're subtracting the entire area, right? If you don't put the parentheses, in reality, you would only be subtracting that first term. So you got to subtract everything. You got to have in parentheses. Now, I didn't need a parentheses on this first one, although it wouldn't hurt to have it. I don't need it because there's a 1 in front, so I don't have to have those. All right. 3x squared plus 12x plus 4 minus x squared minus 2x minus 1. You got to collect like terms there? So I did that without highlighting and stuff. All right. Either I'm going too slow or I don't know what's going on. Y'all feel okay? Am I dragging too much? All right. I don't think anyone would ever tell me like, hurry up. Let's do more so I have to remember more so I can be tested on more. All right, so where are we at now? Where's my page? Where the heck did it go? How did I jump ahead so much here? That's kind of weird. There we go. When do we break? When did I say we break? We started at what, 2? About 2:15, right? Normally a college algebra class is an hour, 15 minutes, right? Yeah, like a normal semester, twice. Well, they do have the 4-hour college algebra. Fall is probably a flex or something, yeah. So a traditional class, fall semester, spring semester, is an hour, 15 minutes. We are doubling that when we're here, and so I'd like to take a break at like when we would normally stop class in a regular semester. So another 15, 20 minutes. See if we can get through how much of this page we can get through here. Yeah, the rest is homework, so let's see what we do here. Factoring out the greatest common factor. You may have heard this before, GCF. So what we are shooting for here is doing that process, remember, we had alluded to it a second ago, factoring. We're trying to turn an expression from having addition and subtraction between terms into somehow having multiplication in it. And that becomes very valuable to us later. So greatest common factor means what you do is you look at each term, every term, not just 2. You know, if you have 5 of them, you can't just look at just 2. You've got to look at all of them and see if there's something that they all contain. So we'll start with numbers. Is there a number that goes both into 6 and to 6? 6. So 6, would be part of my greatest common factor. And now you look for variables. Is there a variable that appears in both? No. So 6 is the most that I can, what we call, factor out. So after I write down the greatest common factor, I write a set of parentheses, and I leave enough space here for how many terms? Y2. You started with 2 terms, right? That dictates how much room you need in your parentheses. If you started with 3 terms, you would need space for 3. So now you just ask yourself a question. What do you multiply 6 by to get 6y squared? Or you could ask yourself a question the other way. What's missing, right? All you're missing is y squared. So y squared I would need. And then here, to turn 6 into 6, I just need to multiply it times 1. But you have to have a second term in here, right? You have to. Plus 1. One of the mistakes I see students make is they just leave and they say, oh, I don't need anything because I already have a 6. The problem with that is if you multiply these two together, all you get is what? 6y squared. You never actually produce the 6. So you need the plus 1 in here so that if you were to distribute it through, you would get back the original. This is our answer. We have factored it, haven't we? We have multiplication in here now. Right there. We have multiplication right there. Let's look at the next one. Start with the number. Is there a number that goes into both of these? Into 1 and -3. The only number that goes into both 1 and -3 is 1, or -1. But there's no number other than 1 or -1 that goes into both. So I don't need to pull out any numbers. Now let's look at variables. Are there any letters that are common to both? Y squared, right? We have y, but we actually have, what we say is, we don't say we have 2 y's here. We say we have 2 factors of y. I have 2 factors of y, and I have 2 factors of y. The difference being, if I say I have 2 y's, what I would really mean is 2 y's. I don't have 2 y's. I have 2 factors of y's. 2 factors of y. Y times y. So that means since they both have 2 factors of y, I can pull out 2 factors of y, and I need space for 2 terms because there were 2 to start with. So when I look up at y squared x, I'm starting with y squared. I need to be able to multiply through and get this. So what's missing? X. And then on this one, the only thing missing is the -3. The good thing about these, you can check them, can't you? All you do is multiply through, and you better get it back. Better get back that. Next one. Start with numbers. Are there any numbers that I have in common? 3 goes into both 3 and 6. So we're going to pull a 3 out. And x, I have 2 factors of x here and 1 factor of x here. So you can only pull out what they have in common. They both have 1x, but they both don't have 2 factors of x. So I can pull a single x out, and then I close it off, and I go ahead and come up with space for 2. What's missing? What do I need to multiply 3x by to get 3x squared? An x, so I'm missing an x. And then plus what? Just 2, right? I don't need an x because I already have it out there. We haven't taken a poll today. We should take a poll. Aren't your clickers around you? Just pick up a clicker. I haven't even asked the question yet. Hold on. Okay, so just any 1 is yes, 2 is no. Are we good on everything I've covered? Yes or no? Answer 8 doesn't count. All right. All right, so I'm assuming like everybody is following. There are no questions. Everyone's good to go. All right. All right, just tell me right now, if I'm able to pull out GCF, how much room am I going to need in my parentheses? Enough for 3, right? So sometimes you start getting into a habit of actually doing that first, and then just trying to figure out what they have in common and pulling it out here. You don't have to. 4, 4. I agree that 4 goes into all of them. Is that the biggest number, though? 8? Yeah, 8 doesn't go in 28. 12, 16. 4? Everyone agree? 4? Okay, so 4 would be the largest number that we can pull out. How about x's? Do I have an x in all of them? No, I'm missing one in the last term, so I cannot pull out an x. Y's? How many factors of y can I pull out? 2 factors of y. And that's the most. That's it. There's no other letters. We're good to go. So I like to do this. Multiply 4 times what to get 16? 4. Okay, I also need up here an x squared. I don't have any x's down here, so I'm going to need the whole thing. X squared. How about to get a y squared? I already have it, don't I? So I do not need to put anything there. And that's it. We've got the first term. Now, how do I turn a 4 into a negative 28? Multiply it times negative 7. I need an x. I didn't have any x's here, right? So I'll have to put an x in there. Y squared, I already have it. So we're done with that part. Move on to the next one. Turn 4 into 48. 12, positive. And then I need the y, 5 factors of y. I have 2 factors of y, so y cubed. I'll need 3 factors of y. That's it. Try that one on your own. I'll check with you in a second. While you're trying this, I'm going to ask the class, because who wasn't here last time? Just one? What was your name? Raven. Okay, so Raven, class is going to share some information with you. Let's see if they remember. Are we allowed to have our cell phones during class? Okay. What's the consequence of being on your phone during class? Off of your next exam. And you have to leave and you're counted absent. Now, I wouldn't expect Raven to know that, but now you do. Okay? All right. Well, if you're on your phone, which Raven was, but she didn't know the rules. Yeah, if you're sitting there like texting during class or messing around on your phone, I know it's really a shitty rule, but I don't know who made that rule up. What happens when I say, okay, let's take a break? What happens? Everyone's on their phone, right? That's what would happen if I didn't have that rule. We would have like 4 or 5 people on their phones all throughout class. Walk around the hallways, just look in the rooms and watch. That's all you'll see. I'm not okay with that. So, or high school, yeah. Good for you. Oh yeah, getting pages. Somebody check my math and tell me if that looks good to you. Let's take a break. Finish this up. Make sure you get that answer. Once you do, take a little break. Let's say we'll start class back up at 3:20. So break out the phones, let everybody know, update your status. If you want to take pictures of like you in the math class, like selfies up here with the board in the background, it's cool. I did. Yeah, I kind of had to, because none of the, like a lot of universities have like podiums. They don't have, they don't because our old, am I stopped recording? I better stop.